Do you want to learn how to build an ASP.NET Core Web API from scratch? In this video, I will go step by step and create a brand new ASP.NET Core Web API using .NET6, and I will use Entity Framework Core to first create our API with an in-memory database, and then I will show you how easy it is to switch implementation to a SQL Server database. Please watch this video right till the end so that you don't miss any details in between. If you like this video, please hit that like button and comment with a heart emoji. Also subscribe to the channel so that you don't miss my next upload. With that said, let's create a web API using ASP.NET Core. I have created a folder for myself in which I will create the ASP.NET Core Web API. After that, I will open Visual Studio 2022 and I will click on Create a New Project. From this list, I will select ASP.NET Core Web API and click Next. And in here, I will specify a name for the project and the solution, and I will also give the location of the folder. After that, click Next and choose a framework. We are on .NET6, which is the latest as of the time of the recording of this video. So I will choose that and I will select all the default options and click on Create. Visual Studio has created an ASP.NET Core web project for us. And inside here, we can see only one controller and there's a class file supporting that controller. We also have a program file in which is the starting point of our application. As you can see, we have some services which are injected to it, and we are building the service over here. And after that, we have the HTTP request pipeline, and then finally we run our application over here. Let's first try to run our application and see what we get out of the box. You can run your application through this Contacts API button, or you can run it without debugging. So I'll use this button for now. When our application is running, you can see the Swagger UI documentation, and inside here you can see all the APIs that you have created inside your application. And this is the weather forecast controller that was given to us by default from the Visual Studio, and inside here we get all the methods that are defined for that API endpoint. For example, we only have the get endpoint for the weather forecast. So if I expand this get endpoint and if I click on try it out, you can actually use this documentation to make HTTP calls to call our database. In this case, this is a static file, which is, if we go back to the code and if we open the controller, we have the static list of weather forecast, which is coming from this file as well, which is a static file. It's not talking to a database at the moment, but it's still returning some values. So if we click on execute, we find that we are getting the list of the weather forecast values back to us. This is great. We have some documentation out of the box, and we also have a default controller. But what if we want to add our own controller and endpoints? In the next few minutes, we will do that. We will create a controller and we will create a static implementation of a database. So we will not use a database directly, but we will understand how we can use in-memory database, and we will first call that. And after that, once we are comfortable doing that, we will actually use Entity Framework Core to create a new database, and then we will save and fetch values from that. We have come back to our application, and the first thing we will do is to install the in-memory package. And we will install this from the NuGet Package Manager library. And to do that, I will come over here to Dependencies. I will right click on that and I will click on Manage NuGet Packages. In here, I will search for this package, which is Microsoft.entityframeworkcore.inmemory. I will copy and paste that. I will click on it and install the latest version. The package has now been installed. It is now time to create some domain models for our Contacts API, ASP.NET Core Web API. So I will come over here, and in the solution, I will create a new folder. I will right click on that, add a new folder, and I will call this models. Inside the models, I will create a class. So I will click on add a class, and I will call this contact. This will be our contact domain model, and inside that I will have a few properties. The first property I will have is a GUID of ID, and after that I will have a string of full name, which will have the contact's full name. After that, I will have an email address for the contact, and that will be of type string as well. And then I will have a phone number, which is for the contact, which will be of type long. And finally, I will have a property of address, which will store the physical address of the contact, and that will be of type string. Now we have the contacts domain model, and we also have installed the in-memory database package from NuGet. It's now time to create a class file which will talk to our database, which will act like a domain access layer. Because we are using Entity Framework Core, we use the concept of DbContext, which acts as a class that talks to the database no matter what type it is, and it also fetches and retrieves data for us. So let's create a DbContext. I will click on solution, add a new folder. I will call it data, and inside data I will create a new class file. I will call this the contacts API, which is the API name, and followed by the word DbContext. So contacts API DbContext. Inside the class, this class will actually inherit from the class DbContext. Click Control dot to import the dependencies. This is using Microsoft.Entity Framework Core, which got installed when we installed the in-memory database package. After that, we have to create a constructor. I will put control dot over here, and I will use this generate constructor, to which we are passing the options, and the options are being passed to the base class. After that, in the DbContext, we have to create properties which will act as tables for Entity Framework Core. So I will create a property over here, and because we only need one property, which is our contacts model, and we only want to retrieve, update, delete, and add contacts, so I will have a dbSet property of type contact. I will import this contact from models, and I will call my property contacts. It's now time to inject this contacts API DbContext into the services of the solution, and we will use dependency injection later on to inject that injected service into our controller so that we can talk to our database. I will come over here into the programs.cs file, and right below this line where I am injecting the service for Swagger, I will use the builder.services, and I will write add DbContext because I want to add the DbContext, and I will give the type of it, which is the contacts API DbContext. Click control dot and import the using statements. So this is coming from contacts API.data, the one we created. And after that, I will give some options to it. I will tell it to use the in-memory database. So I will say use in-memory database. And over here, if you do control dot, you can use this package Microsoft.Entity Framework Core, which gives you that option to use the in-memory database. After that, we have to give the database name. So in strings, I can give the database name, which can be contacts.db. And finally, I will close my brackets. Now we have given Entity Framework Core everything it needs to create an memory database, and it also knows about the tables because we have given it a dbSet as well. Now it's time to create a controller for ourselves and inject this DbContext so that we can read and write from this in-memory database. So I will come to controllers, right click and add to create a new one. I will use the MVC controller empty, click on add, and I will give it a name of contacts. So this will be our contacts controller.cs. First of all, I will annotate my controller with the keyword API controller, telling that this is an API controller and not an MVC controller. And after that, I will give a route to my controller. And the route of the controller would have, again in strings, let's say going to API / the controller name, which is contacts. And another way to give contacts, because that's the same name as we have of the controller, is to give it in brackets like that, and specify the word controller. This is acting the same as the one we had before, which is /contacts, but this time it is taking the controller name, which is contacts over here, and injecting it over here in the route. So this is acting the same way as we had over here as contacts. So now that we have defined the data annotations for our controller, it's now time to create our first method, which is the get method. So I will edit the auto-generated method over here, which is index. So I will call this get, or you can call it get contacts. You can also call it get all contacts. And this is of type, this is returning an action result. That's fine. We will annotate this method with the HTTP get keyword. By default, ASP.NET Core is automatically identifying this as a get method, but for us to use Swagger UI, because we use the documentation, which is the open API documentation, we have to annotate this with the HTTP get keyword as well. So we have created this method. Now we want to inject the DbContext because we want to talk to our in-memory database. So I will come over here and I will create a constructor. The short form is CTOR and tab. In here, I will inject the DbContext, and the name of our DbContext is contacts API DbContext. So I will write contacts API control dot, and I will use this from here, and I will call this DbContext. And I want to create a private property, so I will put control dot and use the same name. So now I can use this private read-only field DbContext to talk to my in-memory database. And in here, I will come over here and I will use this DbContext field to put a dot to say talk to the contacts table, because we have given the dbset property inside the context, and it knows that contacts is a table in our database. So I will talk to the contacts table and return a list. And I can directly call the return keyword over here, and I don't need the second line. If you look at it, it says that we cannot implicitly convert the type generic list to an action result. So either you have to wrap it inside an OK statement to give it a 200 response, because this is a RESTful API, or you can give an enumerable over here like we had in the weather forecast API. So it was an enumerable of the type, so we can pass in enumerable of the domain model, but I want to give it the action result, so I will wrap this inside an OK response. So that looks good. It's now time to run our API to see if everything is working. We don't have anything in the in-memory database, so it'll return an empty list, but later on we will define methods for adding a new contact and other stuff. So I will run this application. As you can see here, now along with the weather forecast API, we are also getting the contacts API, and inside that we have one get method. If I expand on that and click on try it out, I can click on the execute button, and this is trying to talk to our in-memory database and trying to fetch all the contacts for us. And you can see the response is 200. In a RESTful world, 200 means a success response, and you can see an empty array. Because we don't have anything in the in-memory database, this is returning an empty list. So it looks like this is working, but we'll come to know more when we add a new contact inside that, and then we try to retrieve those all contacts. Coming back to our application, it is now time to implement the add contact functionality. So I will create a method first, which will be public action result, and I will call my method add contact, and this will have the keyword, the HTTP verb of HTTP post, because when we add a new contact or when we add a new resource, we use the HTTP post verb. In here, we will first have to get some values from the user. So I will use another model and I will create a request model. So I will create a class and I will call this add contact request. So we have created another model because we want to get only certain fields from, and we want to store it in the database. And if you look at it here, we have 5 fields in total, but we don't want to get the ID from the user. We want to give it our own ID. So I will copy these 4 fields and I will paste it inside the add contact request, because I want the user to only specify these 4 fields, and I will give the ID myself inside the API. In here, because we have created the new request object, I will use that. I will import it from contacts API.models and I will give it a name. Using this, I will create the contact object. So I will first create a new contact object. So a variable of contact is equal to new contact. And inside here, the first thing I'll do is I will give it an ID, and that will be a new ID. So I will use GUID.newGUID. And after that, I will use the objects coming in from the request. So address would be add contact request.address. And after that, we will have the email, which will again be coming from that. And we have the full name, which is coming from the request object. And then we have the phone, which is coming from request object.phone. So here we are doing our mapping between the add contact request and the contact domain model. And this is what goes inside the database. So that's why we have created that. And now we can talk to our DbContext or our database using the DbContext and store this new contact. So I will come over here and I will use the DbContext to talk to our table, and the table name is called contacts. And after that, I will use the add method, and the add method takes the contact model. You can see it over here, and I have the contact model, so I can copy that and paste it over here. I can also use the add async method. So if I use async, but because I'm using the async keyword, I have to use the await over here. And because I'm awaiting on a method, I have to declare this as an async method. So now we are adding this object in the database, and with Entity Framework Core, you also have to save the changes to the database before you can actually see the changes. So I will use await DbContext dot save changes async. So now our method becomes an async method. Now finally, when we have added our resource to the database and we have saved the changes, it's now time to return the request. So we will use the return word with an OK response, and I will send the request that we created, which is the contact, wrapped inside an OK response. And if you come over here, it's complaining about something. It's saying it's not a type of task of type something. Because we are using an async keyword, the iAction result has to be wrapped inside a task, and that makes our method asynchronous. We can do the same thing over here as well. So I can use the async keyword, use the task, and wrap the iAction result in it. And because we are using an async method, we have to use we can talk to the database asynchronously, and here I will use the keyword toListAsync, and I will use control dot to import this using statement. And because we are using an async thing, we have to use the await keyword over here. So this makes both our method asynchronous. Now we have the add functionality. It's time to test it using Swagger. So I will run my application. On running my application, I can see another method being created inside the contacts endpoint. I have the post method, which is going to API/contacts. And if I expand on that, click on try it out, I now have a request that I can send in. So I'll send in some details from here in a JSON object, and that will get mapped to the add request object that we created, and it will try to store it in the database. So I will first populate this, So I have created a JSON request and I'll paste it over here to save some time. And this is just example values over here. And now that that's filled, we have filled our 4 properties we want to send and save it to the database. I will click on execute. And as you can see, we got a 200 response back, which we know is a success response. And the response body was the same that we sent, along with the newly created ID for that contact. So now that we can see it's a success response, we can also try to go to our contacts API to get all the contacts. And previously, where we were getting 0 contacts back, if we try it out now, we should get 1 back. So you can see it's a 200 response, and the array which was empty before has now 1 contact. Keep in mind that because this is an in-memory database, the moment we close our application here, the memory would be cleaned up and the database would have 0 results back. So as long as the application is running, you would have results populated in it. But once you close your application and restart your application, you would see the default in it, which is no contacts in our database. Back in our application, it's now time to implement the update contact method, and we will come over here and create a new method for it. So public async task of type action result, and we will call this method update contact. And the update contact method, because it's an update, we will use the HTTP verb put for it. And we also want to define a route because it cannot go to the same route. The route for this one will have the keyword ID in it, because we want to take the ID of the contact that we are trying to update from the route. So in here, inside the string, I will use curly braces and I will specify the word ID, and it will be of type GUID because we are using IDs of type GUID in our model, as you can see over here. And because it's a type of GUID, I can make it type safe by using the word GUID in here. And because this is coming from the route, the first parameter our method will take is the ID, which will be from route, and it's of type GUID, as we know. And the name of the parameter would be the same name as it's here, as it's coming from the route. So if you have defined a different name over here, it has to match the name over here. So I will define it ID because I've defined it in the route. And now that we have the ID for the contact, we also want to know the updated fields. So similar to what we had over here, I will create a new request object. I will create a class and I will call this update contact request. This will have all the properties we want to update for that contact. So if you look at the contacts model again, we have 5 properties, and we'll ask this question that do we want to update the ID of this property of this contact, and the answer is no. But do we want to update all the other properties, to which the answer may or may not be yes. In my case, it's yes. So I will copy all of these 4 and paste it inside this update contact request. Now the question may arise that because update contact request is similar to add contact request, why are we not using that? Because the name is totally different, the use case could be totally different, and we are achieving a separation by doing that. So we create different request objects for every call, and we can now use this request object, which is update contact request. And I will use the name of it as well. And finally, now it's time to implement the method. I will first use this, and I will first actually try to check if our database has this value to update or not. If it doesn't have it, I will return a not found back. So I will first use, I will try to go to the database. So DbContext dot table, which is contacts, dot find. I will use the find word, and the find takes an object or key values. So I can use the ID over here, and because the ID is a primary key, a unique identifier, it'll try to find that ID in our database, no matter what it is. It's an in-memory or a SQL Server database, so it will try to find that ID in there, and if it finds it, it will return it to me. So I can use var contact is equal to that, and if the contact exists, we will try to update it. If it doesn't exist, we will return a not found back. So I'll first check if contact is not equal to null. That means it exists. We will do some more stuff here, but otherwise return a not found back. And this tells the user or the client that we were not able to find this ID, so we can't proceed further to update this contact. In here, if we found the contact, we will use this request to first form our contact request, and then we will update the existing contact. So we are believing that this contact was found with the ID of this, so it's now time to update the properties. So I will use this contact and I will update the properties that I want to update. So full name would be coming from the request. Contact dot address will be coming in from the request. After that, I will update the phone, and finally we have contact dot email is equal to the request dot email. So we have updated the four properties, and it is being tracked by Entity Framework Core. So all we have to now do is save these changes back. So I will use DbContext again, and as we used the save changes in here, we will call save changes async, and I will use the await keyword. Let's try to see if the find also have a find async, which it does. So I will use the await keyword over here, and now our method becomes asynchronous. After I have saved these changes, I want to return the response back. So I will use the return keyword, and it will be of type OK, meaning a success response. And I can now return the updated response back. So I can return the updated contact back. So that's done, and it's now time to test it. We can see our update method over here, and let's expand on it and click on try it out. It needs an ID, and it needs a request object which we want to update, but we don't have an ID, because if we come back to the get all contacts, click on try it out, as I told you before, because we have restarted the application, our our contacts list have been cleared out, and we want to first create a contact before we are able to update it. So I will use the same request again, and I will come to the add method, click on try it out, paste it and execute it. This has created one contact for us. I can minimize that now, and if I execute get all contacts, you can see one contact being created. So now I can come to the update, and I can use this existing contact. So I have to first copy the ID and paste it over here. And if I don't do that, if you see here, it's a required field, and if you click on it, it throws an error because it needs a valid GUID. So I will paste it over here. And then, just to save my time, I will also copy this object and paste it over here. Now the update request object doesn't have an ID, so I will first clean that. And now we can play around with the values. These are existing values, but let's say we wanted to change something. So the address has been changed from 1 some street to 2 some street, and then the phone number also changed. And because we have made some changes, if we try to execute and update our contact list, let's see what happens. So I'll click on execute. we can see a 200 being returned back and the updated response, which has our changes. But just to confirm that the changes are in the database, we will come back to our get all contacts and click on execute. We can see in the get request, the details of that contact have been changed, and these values are coming from our in-memory database. So we can say that our put operation or the update operation is now working fine. So it's now time to create the delete operation, and also we want to implement the get operation for getting a single contact back based on an ID. So let's create these two methods and then test them together. Let's first create the get single contact because that's an easy one. So to get a single contact, I will place it along with the get operation to get all the contacts. I will first create a method, public async task of type iActionResult, and I will call this get contact without the word s because it's a single contact, and I will annotate this with the HTTP get keyword. And I will also give it a route because we want to take the ID of that single contact that the user wants to search on. So I will create a route, and the route will be similar to what we had in the update. So I can copy paste that, but to explain, it takes an ID in the route. And because we are taking something from the route, I'll use the from route keyword. And I will use the type of it, which is GUID, and the name, which is ID. So this should match again the one coming from the route so that it can map the values from it. Now an ID is coming back. As we did something in the update contact, we tried to find the ID from the database, and then we returned the result. We will do something similar over here. So we can actually copy this line and paste it over here. What it's trying to do is it's trying to talk to the database and the contacts table to find the ID, to find a resource with the primary key of this ID. And if we get one, we'll return it. If we don't get one, we will return a not found back. So this could be as simple as if contact is null, then return not found. And you can pass a message in the not found as well, but I'm keeping it empty. Otherwise, just return the found contact. And return the found contact, but we have to wrap it inside an OK response. So now we are returning the request. We are returning the contact back in a 200 response based on the ID that is being passed. And we will test this along with our delete. So let's first implement our delete, and that will be again a public async method, task of iActionResult. The method name will be called delete contact. And delete also, if you think about it, you want to delete a single contact, right? So you will use the delete keyword first. So HTTP delete. And if you think about it, you need an ID to delete. So I will use the same route again. And because we are using the ID from the route, we have to use the mapping over here in the parameter of this method. So this is coming from the route. It's of type GUID. And the name is ID, which matches this one. And if you want, you can also remove this because ASP.NET Core is smart enough to understand it's coming from the route, but just for demonstration purposes, I'm keeping it over here. We'll do a similar thing of what we did inside the contacts. So first we will go to our DbContext. We will talk to our contacts table and try to find a resource with the primary key of ID. Store it in a variable, and we will check if the contact was not null, that means it was found. Then the request is to delete it. So we will delete that object from the database. So using DbContext again, we use the remove method, and we pass in the object or entity that we want to remove. And in this case, the entity is contact. So I will pass contact in that remove method. And this hasn't been completed yet because you have to save changes. So I will use dbContext.saveChanges. I can use the save changes async and put the await keyword in front of it. And if this contact was not found, I will return a not found again. And if this was successful, for example, the ID was found, the resource was found in the table, we have removed it, we have to return a response. So we can return an OK response, and you can pass in anything you want. You can pass in this was deleted or this contact was deleted. I am happy to pass the contact back in case the client wants to do something with it. So we have implemented our get single method and delete as well. So it's now time to test it. So I'll run my application. As we can see here, now we have multiple methods inside our contacts API. And the one that we want to test is the delete and the single get with the ID. But before we can proceed, because we restarted our application, we have to insert a record to be able to edit or delete it. So I will use the same JSON again. So I click on try it out, paste that same JSON, click on execute. And that creates a new contact in the database. I can minimize that and click on try it out, which will give all the requests over here. So let's say, for example, we wanted to have two results in here, two contacts. So I'll use the add method again. And this time I'll change the name to my name. And let's just update the email. This is surely my real email. And if I click on execute, we have another success back. So the get all response should now have two objects and two contacts in our contacts API. So first of all, I will demonstrate the get single contact back. So I'll use my ID with the name of my name, and I will use the ID of it to fetch details for a single contact, which is this method over here. And as you can see, it takes an ID inside the route of it. And if I click on try it out, paste the ID and click on execute, it gives you the result back, and you can see it's my name and not the other contact. And that seems to be working. And finally, if I wanted to delete this contact, because we have the ID copied, I can click on here, click on execute. And as you can see, it returned the 200 response with the deleted contact back. And just for fun, because we know it's deleted, if we try to do it again, we should get a 404 back, which is a not found. If I click on execute again, we find it that the application, the API is saying we are unable to find this resource in the database. So we have not deleted it. So it's saying a 404 not found back. So we can see that all our methods and implementations for the API endpoints are now working, but all of this is still using an in-memory database. So whenever we close our application, the database gets cleared and it's not really persisting anything. So now we want to change our implementation from using an in-memory database to a SQL Server database. And now we'll see how easy it is to switch providers once you have the base implementation in place. I have stopped my application, and now it's time to implement SQL Server database and try to store our values inside an actual SQL Server database. So to do that, we first have to install a few Entity Framework Core packages, and these are Entity Framework Core.SQL Server. We will not install the first one because it got installed as part of the in-memory database installation. So we will first install the SQL Server. I will come over here, right click on dependencies, click on manage NuGet packages. In the browse section, I'll search for this package. I will click on it and install. Then I will search on the next package, which is Entity Framework Core.Tools. And this is responsible for creating the database for us by using Entity Framework Core migrations. So I will click on it and install. Now that we have installed the packages, it's now time to first create a connection string, and we create connection strings inside the app settings.json. So I will come to this file, and below the allowed hosts, I will create a connection strings property, and I will create a key, and I will call this the DB connection string name. So contacts API connection string. And the value for it will be server, and I have installed SQL Server on my machine, and I'm using this server. So if you can go online and search for how to install SQL Server, and also I'm using Microsoft SQL Server Management Studio to query my database. So this is SSMS. So you have to do 2 installations to reach here, and if I try to connect to it, you can see the server name over here, and this is just a local server. So I will copy this. So you have to copy the server name that you are using. And if I refresh on this server, you can see there's no database that's called contacts API DB, but we will create one soon. So I'll come back and I will provide the server name that I copied. So you have to replace this value with whatever server you are using. After that, I will mention the database. As we saw, we don't have a database, but we want to create one, and we want to create one using the name that I'm specifying now, which is the contacts DB. You can mention your own name, and after that we have to specify trusted connection is equal to true. So trusted underscore connection is equal to true. And with that, it's now time to use this connection string, and where we injected the in-memory database. So I'm coming back to the program.cs file. We used this line, which is the in-memory database. I will copy paste it one more time and comment the other one. I will replace the in-memory database with the SQL Server implementation. So I will say use SQL Server, and for SQL Server, if we open the brackets, it says that we can give it a connection string, which is of type string. And we have already defined the connection string in the app settings. So we will take the value from here. Coming back, I will use the builder.configuration to access that value. So builder.configuration, and I will move this to the second line. And I will put a dot to use this method get connection string, and it takes a name which is the same name as we have over here, which is the key. So use the same name as you have defined in your app settings.json. So I will come back to the program.cs file and specify this name inside a string and close the brackets. And that's it. We have replaced our in-memory implementation with actually using a SQL Server implementation. And Entity Framework Core also has options to use a Postgres database or a SQLite database. So you can use whatever you want to like. And after that, we don't have to do anything. We just have to create the SQL Server database using migrations. And to start migrations, we come to Tools and we go to NuGet Package Manager and open Package Manager console. In here, we will type 2 commands. The first command is add-migration. So I will copy that and paste it over here. And after that, I want to give the name of the migration in quotes. So I can say, because this was the first time I'm creating a database, I can call it the initial migration. And I will press enter. And this is creating a migration for us, meaning it's creating a class file with all the code required to create a new database. And we will soon see that a migrations folder has been created over here if everything goes fine. So you can see a new migration folder over here, and inside that we have the initial migration class file. And if you look at it, it has 2 methods, an up method and a down method. If we expand the up method, it has everything it needs from the DbContext file to create a new database and to create a new table with all the properties required. So it's actually from a C# world, it's actually creating us a SQL database and tables for us. So I will come back to my package manager console, and after that we will use the second command, which is update-database. And with that, I'll just press enter. And update database, which will actually run the migration. So till now we hadn't had anything in our database naming, called contacts API. So I'll come back to the SQL Server, and if I refresh on the server, expand databases, we have a contacts DB now. And if I expand on the tables, the table name, the only table name that we have inside our API is the contacts API. And if I select star or select top 1000 rows in there, you should see 0 values because we haven't inserted anything at the moment. So you can see 0 values in here. But now let's run this API and let's try to add new values to it and see if our API is still working with the SQL Server implementation. I've run my API, and as you can see, we have these options that we can trigger. First of all, let's see if our API has got any contacts at all. So if I click on try it out, you can see it's taking more time because it's now making a connection to a SQL Server database and not an in-memory database. And you can see a 200 success response back, but it doesn't have any contacts in it. So we will use the add method to first create a contact. So I'll copy the value of the JSON, and I will come to my post method and paste this value, and we will try to create a new contact. It came back with a success. It also has given us an ID, and let's see if we are able to get those contacts now. It was empty before. If I click on execute, it now comes back with a contact back. And we believe that it's not using an in-memory database, but it's using a SQL Server database this time. And to confirm that, I'll come back to my SQL Server. We had 0 rows returning, but if I click on execute again, we now can see the values are getting persisted inside the SQL Server database, and we are no longer using the in-memory database. That was great for our development purposes, and we used that to do quick testing before any implementation was needed. So now we will go ahead and test the other operations as well. I'm pretty sure they will work, but first of all, I will create another object over here, or another contact, and click on execute. Now if we get execute again, we have 2 records. Let's use the same testing. I will use the ID with my name in it, and first of all I will try to update it, or let's just delete it, or let's get it first, anything. If I pass the ID here, click on execute, it should get the ID with my details in it, as you can see. So now we no longer require this ID, so let's delete me, click on try it out, pass the ID, click on execute. And as you can see, a 200 back, which means a success response. So this has been deleted. To confirm if it has been deleted, I will execute that. And because we never saw the other one again, it comes back with 0 rows back. And if I now still want to delete this deleted contact, it should say we are not unable to find that resource in our database, so we can't delete it. So we have tested these. The final one to test is our update, and we will use the other ID, and let's update this list as well because there should be only one. And if I pass the ID over here, and if I pass an updated request, so I'll copy that to make things faster, I'll actually update all of this to my details from John Doe. So using this ID, I will update this ID to be my contact now. Click on execute, success response back. And let's quickly confirm that by going to the database, this ID was John Doe, but if I execute it now, it becomes me. So all our operations, the CRUD operations, which is create, read, update, and delete, are now working for our contacts API. I hope you enjoyed this tutorial and had great fun implementing this alongside me. If you did, comment a heart emoji letting me know what's the best thing you liked in this tutorial. Also hit that like button and don't forget to subscribe so that you can get updates to my next upload. Thank you for watching. See you in the next one.